Document retrieval in the real world is a mess. You're dealing with scanned PDFs, complex web pages, charts, slides, and mixed layouts. Traditional pipelines rely on OCR to extract text, then feed it into lexical models like BM25 or dense retrievers like DPR. But OCR introduces computational overhead, recognition errors, and completely ignores the visual layout that often holds the key to understanding a document. On the flip side, the recent wave of parsing-free methods using vision language models tries to skip OCR entirely by feeding document screenshots directly into the model. They're excellent at capturing spatial structure, but when you hit text-heavy scenarios, they struggle to grasp fine-grained semantic details. For years, we've been forced to choose between layout awareness and textual precision. A new paper from researchers at Peking University, CAS, and industry partners introduces a framework called Unveil that actually bridges this gap. Unveil stands for Unified Visual Textual Integration and Distillation. The core idea is elegant. Train a powerful visual textual teacher model that leverages both OCR text and document images, then use knowledge distillation to transfer that semantic understanding into a purely visual student model. The result is a flexible retrieval system that gives you state-of-the-art accuracy when you need it, and high-efficiency, parsing-free inference when you don't. Let's break down how Unveil actually works. The framework uses a dual encoder architecture for both the teacher and student models. During the teacher training phase, each document image is processed by an OCR engine to extract textual descriptions. These text tokens are then concatenated with the visual tokens from the document screenshot. The combined sequence is fed into a vision language model, specifically initialized with MiniCPM-V2. The prompt structure follows a standard pattern: a start token, image tokens, OCR description tokens, instruction tokens, and an end token. The final hidden state of the end-of-sequence token becomes the document embedding. Queries are encoded separately using the same language model. Similarity is measured via cosine similarity, and the model is optimized using an info-NC loss within batch negatives. This ensures the teacher learns to pull relevant query document pairs together in the embedding space, while pushing irrelevant ones apart. Once the teacher is trained, we freeze it and move to the second stage, distillation. The goal is to train a visual-only student model that never sees OCR text during inference, yet still produces embeddings that behave exactly like the teacher's. To do this, Unveil introduces 3 specific distillation strategies. First is representation alignment. We calculate the L2 distance between the teacher and student embeddings for both queries and documents. By minimizing this distance, we force the student to learn a latent space that mirrors the teacher's textual visual fusion, even though the student only receives image tokens. Second is soft label distillation. Instead of just using hard positive or negative labels, we use the teacher's similarity scores to create a probability distribution over the entire batch. We apply a temperature scaling factor to smooth this distribution, then minimize the KL divergence between the teacher's distribution and the student's. This teaches the student to understand fine-grained relative similarities between documents, not just binary relevance. Third is adaptive reweighting. Not all documents are equally hard to distill. Unveil calculates the KL divergence between teacher and student outputs for each sample, and uses a softmax over these divergences to assign dynamic weights. Samples where the student struggles the most get upweighted, forcing the training process to focus on the hardest cases and preventing the student from just memorizing easy patterns. The total loss combines the representation alignment loss and the soft label distillation loss, weighted by those adaptive scores. Both models are fine-tuned for 2 epochs with a batch size of 16 and a learning rate of 2 × 10 to the negative 5, trained across 8 A100 GPUs. The results speak for themselves. Across 12 datasets spanning visual-rich scenarios like charts, infographics, and slides, as well as text-rich scenarios like web pages and academic papers, Unveil's visual textual teacher consistently outperforms dedicated text-based models like MiniCPM and BGE, and dedicated visual models like CalPoly, DSE, and VisRag. But the real win is the distilled visual-only student. It achieves performance nearly identical to the teacher, while completely eliminating OCR dependency at inference time. This cuts down computational overhead and speeds up retrieval, which is critical for production systems. We can see the mechanics of this transfer clearly in the ablation studies. Removing representation alignment causes the biggest performance drop, which makes sense because the student needs that direct geometric constraint to learn the teacher's semantic mapping. Removing soft label distillation also hurts, confirming that the teacher's distributional knowledge helps the student discriminate between visually similar but semantically different documents. And if you remove distillation entirely, the visual-only model falls back to baseline VLM performance, proving that the distillation pipeline is doing the heavy lifting. There's also an interesting finding regarding text length in the teacher model. As you increase the OCR input length from 0 to 3096 tokens, retrieval metrics steadily improve, plateauing around 2000 tokens. Longer context provides richer textual grounding, but it also increases inference latency. This directly justifies why distilling that capability into a visual-only model is so valuable. You get the performance benefits of long-context textual reasoning without paying the computational tax at query time. Embedding visualizations using TSNE further confirm this. Before distillation, the students' document embeddings are scattered and misaligned with the teacher's space. After distillation, they cluster tightly together, and cosine similarity between corresponding query document pairs increases significantly. The student has genuinely internalized the teacher's representational geometry. So why does this matter for the broader AI landscape? Document retrieval is the backbone of retrieval-augmented generation, enterprise search, and automated information extraction. Unveil gives you a practical deployment strategy. Run the visual textual mode when you need maximum precision for complex or ambiguous documents, and switch to the visual-only mode when you need speed, cost efficiency, or strict parsing-free constraints. The framework handles both without requiring you to train two separate systems from scratch. If you're building multimodal retrieval systems, RAG pipelines, or enterprise document search, Unveil provides a clear, reproducible blueprint. The methodology is sound, the distillation techniques are well integrated, and the results are robust across both visual and text-heavy domains. I'll drop a link to the paper and the official repository in the description. If you found this breakdown useful, make sure to like and subscribe, and let me know in the comments which part of the distillation pipeline you'd want to experiment with first. Thanks for watching, and I'll see you in the next one.